Hello, and welcome to today's Greentech Media webinar, Balancing Cost, Reliability, and Performance with New Module-Level Power Electronic Architecture. This webinar is brought to you for support from our sponsor, KACO New Energy. So this GTM webinar is a part of a series of webinars we do throughout the year to help keep professionals like you in the solar market informed through research and analysis on the latest technologies and market trends. My name is MJ Shiao, and I'm the Director of Solar Research for GTM Research, Greentech Media company. Greentech Media is an online publisher for information on the green and renewable technology industry, and GTM Research is a market analysis and consulting division of Greentech Media. You can stay informed by reading the news on greentechmedia.com or find out more about our research by visiting gtmresearch.com. You can also click the GTM icon at the bottom of your screen for more information about our company. Now, before we begin today, I'd like to take a moment to go over the screen you have in front of you just so we can make the best use of our time that we have today. You'll notice that there's a menu bar along the bottom of the screen with a few widgets, including the download slides button, which does have a link to the presentation that we'll be presenting today. There's also a widget that allows you to share this webinar through your preferred social media outlets. And on the right side of the menu, you can find our speaker bios if you want to learn more about the speakers today. Finally, most importantly, you'll note that you'll be able to enter questions at any point throughout today's presentation with that Q&A box to the left. We'll try to reserve at least 5 to 10 minutes for Q&A at the end of the presentation and hopefully get through as many of your questions as we can. Now with that, I'd like to introduce our speakers today. We first of all have Jon Bonanno, who is the Ultraverter Specialist at KACO New Energy, and also joining us today will be Paul Grana, who is the co-founder for Sales and Marketing for Folson Labs. Once again, my name is MJ Shiao, and I'm the Director of Solar Research. Now, before we get to today's presentation from our guests, I'd like to just present some context for what GTM Research is seeing in the market today as it pertains to today's topic. First of all, as many of you know, the U.S. residential market is growing at an incredible pace. Over the past 5 years, we've seen 12% growth quarter over quarter, which equates to more than 50% compound annual growth. And what's amazing about this growth is not that there is this fantastic growth, but that it's been so consistent on a quarter-by-quarter basis. Now, if we start digging into what's actually happening with systems today in the market, we're also starting to see a change in the architecture, specifically with the power electronics architecture that is being utilized by residential installers on the ground. For example, just a couple of years ago in 2013, we already saw a fairly large module-level power electronics penetration into residential installations. So microinverters and DC optimizers representing about 40% of the residential market. But that's continued to grow through the past 2 years, such that in 2015, we saw 55% of residential installations utilize either a microinverter or a DC optimized architecture. And a lot of that has been driven by the rapid adoption of DC optimizer technology specifically. Now, when you start digging into the market as a whole or the national market, it's one thing to look at the overall national market. But as many of us know, the U.S. is actually comprised of many different state markets, and such that when you start to look at the individual penetrations within each state, the individual market shares, you'll see that there's a very different adoption pattern that's happening that's dependent on what local conditions are. So you could have a place like Massachusetts, which very early on adopted NEC 2014 rapid shutdown requirements, and such that drove so that over 90% of residential installations in Massachusetts today either use a microinverter or a DC optimizer, to the exact opposite where you see somewhere like Arizona, where there's a lot of there's a lot of uncertainty about the rates. The retail electricity rates are low. There are some rate structures that are forcing residential installers to push more towards smaller systems that emphasize self-consumption, and just the mere fact that system prices are incredibly low as well, which also affects the adoption curve for module-level power electronics. To then, of course, then a very balanced market like California, where you do see a competitive landscape that is looking either to differentiate but also looking and focusing on upfront costs. So there's a lot of different drivers for the adoption of module-level power electronics, and certainly as regulations continue to change and as the competitive landscape continues to change, we certainly see that the adoption pattern within these states for module-level power electronics will change as well. Regardless, I just want to wrap up my section here today by pointing out that regardless of what the power electronics architecture is, the future for residential solar in the U.S. is incredibly bright. We're seeing costs continue to come down, and as those install costs come down, while meeting regulatory requirements, while meeting still local requirements as well, we see a spectacular growth curve ahead of us, such that we believe that the U.S. residential market will exceed 5 gigawatts by 2020. So again, power electronics does play a very important part in how installers actually put those systems on the roof and in the ground. And with that, I'll turn it over to Jon at KACO to speak a little bit more on that topic. So Jon?
Thanks, MJ. I also want to thank Paul for joining us here today. It's really an important moment for KACO New Energy here in the Americas. And just a little background, KACO is not a new company. KACO has been around for over 100 years and been doing solar grid-tied inverters for over 2 decades. It's a very important company in Europe, and restarting their U.S. organization. At the helm is a gentleman named Jürgen Krenke, who is the former CEO of SMA Americas. So great leadership, and as you're going to see today, some really exciting new products coming out of KACO New Energy, headquartered in San Antonio, Texas. So it's not just a trivial amount of power that's been shipped and commissioned by KACO New Energy worldwide. There's over 8 gigawatts of power that has been shipped and commissioned. So this is not a new company. It's an old company, and it has a very, very long history of innovation. This is the first transformerless inverter in the world, introduced in Germany, and KACO played a key role in the German growth of their feed-in market during the early days and through the end of their feed-in market. We're now introducing a new product today as part of this innovation history that we have at the company. So the challenge that every installer or system operator faces is that we have a multitude of variable low-power DC sources. And of course, we need to connect them to an AC grid at 240 volts split phase in a residential environment. That, of course, asks the question of what are my solution sets and what are my potential options as far as being a buyer of these products. Historically, the string inverter has dominated the rooftop market. That's primarily driven by price, but now that we have in the introduction of rapid shutdown compliance in NEC 2014, that of course introduced new costs in not only in hardware, but introduces new costs in labor. But traditionally it's been a low-cost option. There's also a very long track record for string inverters, and of course understanding that track record means that you can potentially look forward and plan your financial asset of a solar system. There are a multitude of vendors that make these string inverters, and so that's also nice from the perspective of the buyer. And then these systems, string inverters work on 60 and 72 cell modules, so that's a clear advantage to the string inverter. But there are also some cons here. So there's competitively low energy yield on a string inverter system without any other power electronics. There's added costs for being NEC 2014 compliant. Long-term reliability and replacement costs need to be factored in because there's a certainty in that there will be failures of a string inverter within a 20-year period, at the minimum once, potentially twice. There's also a lack of module-level granularity on your data set that you receive from a string inverter, so it makes operations and maintenance more challenging and less exact. Complex system design and calculation is, of course, a con because we're trying to get as many new entry of labor into this market, and having high education thresholds keep people out of the business, which is, of course, a con. And then having a multitude of SKUs required to accommodate all types of systems, whether they're 2 kilowatts AC all the way up to 9 kilowatts AC. In a typical provider, you might have 10 to 12 SKUs in that, and a stocking distributor needs to stock all that, and that's an inventory risk, so that's a con. The next platform we can dissect a little bit is the historical platform of the microinverter. Of course, the claim of these microinverters is that they improve energy yield, which is in fact true. Module level monitoring is a bonus. It's a safer AC system. It's easy to design these systems and simple to install. Now, the cons of this is that, of course, there's a trunk cable, which is incredibly difficult on a distribution side, and installation is not exactly easy. Expansion of systems is also not a trivial exercise. High cost of this solution doesn't make it particularly attractive, and liquid-filled components on the roof in electric capacitors make it a reliability concern. Heavyweight and large size really prevent it from being married directly to the module itself, and they don't work on 72-cell modules. These are all a balanced approach looking at this particular option as a solar buyer. Moving to the next slide, where we see that a string inverter coupled with an optimizer has some pros, of course, which is improved energy yield. It's a lower cost than a microinverter, which makes it more financially attractive. And the optimizer works on a 60 and 72-cell module. You get module level data, which is a positive. Now, on the other side of things, rapid shutdown compliance in a typical fire safety practice of doing the open main breaker technique, which practically 100% of all firefighters do this as a first step to fighting a fire in a residence, it's not compliant. So we need to be concerned about that from a fire safety perspective. Inventory logistics is also the same as a string inverter. You have a multitude of SKUs that are required to be stocked in order to provide the best service and options for your customers. So a stocking distributor will have to carry all these SKUs. And of course, there's the long-term reliability and replacement costs that need to be factored into that string inverter. So now I'm going to hand it off to Paul to discuss some of the analysis that he's bringing forward.
Thanks, John. I'm again going to assume that everyone can hear me unless I hear otherwise. So as John said, there are a variety of architectures out there, and from our point of view with you, we can speak to the design trends that we're seeing across the market because these trends dovetail in with the architecture choices. So first, starting with a lot of the high-level things that we see as customers are using tools like HelioScope. So basically, it's in a system, you have the bill of materials and figure out the energy yield, really allow them to reassess design choices. And what you see here are really three of the most important design choices. First of all, we're seeing big changes in the tilt of the module and the spacing of the module. Lower tilt, tighter spacing means greater nameplate capacity. You're sacrificing a bit of yield, but you're making it up in terms of the actual yield, or in terms of the actual energy density. The DC-AC ratio is another opportunity, especially when you're constrained in a grid tie point. That's a trend. And the third, the one that I want to dig into a little bit deeper here, is the shade tolerance. So historically, people have been fairly conservative with respect to shade, which makes sense when you don't have the tools to assess it. But in a world where you can actually properly understand and diagnose what's the impact of the shade and what's the appropriate level of shade tolerance to have, what we're finding is that smart engineers, responsible engineers, are reassessing and getting closer to the shade. So specifically what that looks like is, here's an example. This is a residential case where you've got some trees to the southwest edge of the roof. And basically the way HelioScope works is it allows the user to set a shade threshold. So basically, we look at the shade patterns over the course of the whole year. We map where the tree shadows are going to be across the roof. We also understand what the weather is at that point in time. So, of course, if you're in Seattle or if it's December, you care a lot less about December sun than you do about July sun. So that is I'm just switching audio here, just if we have a better connection here. So, trying to make sure that things are sounding good. This variable threshold allows people to set different choices. So, system possible. That 22% shade tolerance, gets you a fill down to 15 or 10 or 7%, you're basically sacrificing system size for the sake of better yield. So traditionally people have been on the left end of the spectrum, 5–7% shade tolerance, or making the choice based on a particular day and time window. But more and more we're seeing people shade up to higher thresholds, meaning you're, in this case, if you think about 7 versus 10, you're adding 2 kilowatts to the system, but you're adding 4 megawatt hours or 3.5 megawatt hours to the energy yield. And so economically, generally speaking, is that when you can do the analysis, you're generally better off because, especially in an era of low component costs, the cost of adding those extra modules, even though marginally they're less productive when 7 to 10%, then you basically are still increasing the total profit of the array. And so really looking at the NPV, it's better off to move to approximately 10%. And in this case, that 10% number is what I hear from a lot of our customers, that even in a traditional system, they're often looking at 10% as the new threshold for having modules in or out. But take that, when you the optimal system often moves up and to the right even further. And note what that means. It means that you can have a greater profit value because now you have shade, and it also means an even greater system size. So even the module manufacturers out there are going to enjoy this story. So again, taking a half step back here, the key trend isn't just that people are reassessing systems, it's that now, as opposed to 3 years ago where most people said, I just don't deal with shade, now a lot of responsible engineers are designing into shade on purpose because it actually improves the economic return of the array. So that, of course, naturally feeds into the value proposition of module-level electronics because now there's a genuine shade story even on a quote-unquote good system because you're going to add that extra few percentage of system size to add the extra economics of that system. So with that, I will hand it back over to Jon.
Thanks, Paul. It's a great point to see that coming out of the data set that you work with because HelioScope is a great tool and people using that for being more aggressive in their design considerations gives some real value, and that's nice to see. Larger systems with higher NPV, net present value on the solar asset, driven by module-level power electronics. So just a quick review to the value of each one of these solutions. A string inverter is typically selected because it's low cost. A string inverter plus an optimizer is typically used because it's a universal solution on 60 and 72 cell modules. And then the microinverter is used typically because it's a simple solution. Now, when you stack that up against what we're introducing today from KACO New Energy, the Ultraverter system, we have a simpler system to design and install. It's universal and works on 60 and 72 cell modules. It's also a low-cost solution in comparison. So let's jump in a second and talk about our design philosophy at KACO New Energy as it relates to Ultraverter. And we take the view of business intelligent solar. And what does that mean? It's the characteristics and features that enable you, the customers, to earn more profit from using a specific solution and looking at the final product and system as the output that will help you make more money. So let's start at the top. As we did with the others, let's talk about the pros of the system, and we'll also balance the cons against that. So it is rapid shutdown compliance without any additional cost and any additional labor. It's a very important point. There's absolutely no trunk cable in the system, no proprietary connectors. It's also the highest yield of any module-level inverter in the world as rated and listed at the CEC. With only 3 SKUs, you can build a 2 kW AC system all the way up to a 9 kW AC system, which effectively covers any or most of your opportunities in the U.S. market. All solid-state components on the roof, and the inverter is agnostic electrically, so you can connect it to a 60 or 72 cell module. On the con side, at 240 volts, there's a limit of 3.72 kilowatt DC per string. It's also a new technology, so there's going to have to be a learning curve for some of the installers and users of the system. But to that point, I would also say that we've got 300,000 hours of runtime in the field of this technology, and so it really is proven technology. It is a limited supply chain. KACO New Energy is the only group that offers the Ultraverter product, so it is a single source in this particular situation. Moving forward, we see a general system overview as this is an introduction to the Ultraverter system. You'll see that the individual units marry one-to-one to the module, and they're connected in a series connection with standard PV wire and standard solar connectors. There's no trunk cable in the system. All of this then is strung down to a smart junction box, which is called the UltraGate, and then that connects via Wi-Fi to the wireless network and also pushes the power out to the grid. So how do you build a system? You build a system with three simple components. The first is the Ultraverter 250, which is a 250 watt AC rated device that sits behind the module on the roof, converting the DC to AC power. It connects in daisy chain in a series connection, and the minimum per string is 8, and the maximum is 12 at a 240 split phase connection for a standard resident installation in the United States. The next piece of the system is the UltraGate system, and this is our smart string combiner box. It has integrated Wi-Fi for simple commissioning, and it also has an integrated disconnect for AC, which means that you don't have to mount a separate box, nor do you have to run conduit, simplifying the work of the installer in the field. This UltraGate houses 1, 2, or 3 Ultra blades, giving you a capacity of 2.2 kilowatts all the way up to 9 kilowatts AC in the same enclosure. The final piece of the system is a smart breaker, which is called the UltraBlade. There's one UltraBlade per string, and it is a grid and string safety protection. So, Ultraverter is not a microinverter. We're going to demonstrate now what a historic microinverter looks like. So you have a 240 volt per unit connected in parallel to the grid. So the transformational shift here is that what we're doing is each one of these inverters is inverting to an envelope that's below 40 volts AC per unit, and then we connect them in series to build the grid voltage of 240 volts AC. Next, we'll see how a typical string works. You have 10 units in series here, and you'll notice that each module, as very typical is the case, has a mismatch. So you have different input availability on the mismatch, and each one of those has an output of voltage which is slightly different and adjusted independently and autonomously. The current remains constant, and you serve the grid at 240 volts. As we introduce a shading effect on the string, you'll see that the available power on that shaded unit falls to 100 watts availability, and the voltage falls as well. All others in the series, again, autonomously and independently, move their voltage up to continue pushing power onto the grid at 240 volts. Even in the condition where you have shading and complete failures of units, you still can provide power to the grid, and this is an important redundancy and reliability to the system. Inside of each Ultraverter 250, there is a mechanical relay that shorts if there's any issue on the device and continues to push power and communications across the string. So in the end, it's a very, very reliable system on the roof. So, as I said from the beginning, business intelligent solar means that we actually need to talk to our customers and listen to our customers. So we're going to discuss 6 key points and real value that Ultraverter gives to our customer. So the first is that this technology is a fireman's friend. NEC 2014 is extremely clear on how we protect first responders to a fire incident. There are 2 methods of rapid shutdown compliance. The first, and certainly the best practice, is that the main breaker is opened at the service panel. The second method is a manufacturer's solution. This requires, of course, the first responders and firefighters to physically switch the switch on the front of the inverter case. The problem with this second method is that it requires double work for the firefighters, which in some cases that delay might cause some issues. The second item that we need to discuss here is that the manufacturer's education program needs to contact all firefighters, not just specific firefighters, because wherever there's a system installed that requires this manufacturing shutdown solution, you need to educate everybody, because I would hate to have people arrive at my house that weren't trained in that specific method. The third item to be concerned about here is that all firefighters have to be aware that this type of system is on the roof, because if it doesn't comply with the first method of shutdown, then there's a problem if they don't know if the system's even there and they don't shut it down. The nice part here is that the Ultraverter is the fastest RSD solution in the market in both cases, with less than 2-second compliance and no additional work or education or cost. The next is increased transaction velocity. We break this down into subsets so that it's easier to understand. So there is only a minimum and maximum design criteria for a string, so this removes the requirement for string calculations. We're also simplifying inventory, so with 3 simple SKUs that we outlined before, you can build anything from a 2 kW AC system all the way to a 9 kW AC system. This is also a faster installation because there's no trunk cable and everything's connecting in a daisy chain solution. So in fact, we're removing some of the headache of the trunk cable from the system. All of these attributes lead to increased transactional velocity, which increases your installer profit. So we've also really thought and listened to our customers on the fact of mitigating IT headaches risk is critical. The Ultraverter system does not require anyone to pull Ethernet cable. That's a major benefit. Also, in our system, there's a very mitigated crosstalk element because we have deterministic performance because there's a high-pass filter in the system, which creates a private network and a very quiet power line communications channel. Also, we're commissioning with a rich mobile application rather than a sometimes a solar-deprived display on the front of inverters. Rather than what we're doing is we're using a mobile application that has a very rich interface for commissioning. We're taking away those problems in the field. The next is reliability. Reliability is a key element to long-term success in the solar business, part of our business intelligent design. So the Ultraverter inverter has been tested to approximately 35 years of testing at the equivalent of 185 F with 85% humidity. And just to give you an understanding of what does 85% humidity mean in the real world, well, the average humidity in Florida is 74%. So we're very much in the market here with a product that can live anywhere in the world and succeed out to the 25-year warranty. We've also completed halt testing that indicates that there will be a 0.05% annual failure rate. In comparison, string inverters on average are about 1.5 to 2% annual failure rate. Finally, let's look at the testing that's actually happened in the chambers themselves. Over 3,500 hours of damp heat without failure, 43,000 power cycles without failure, 800 thermal cycles without failure. These are typically 3 times IEC standard. Finally, we're taking it very seriously at the manufacturing level, where we're using IPC Class 3, which is military and space grade, where all competing technologies are using IPC Class 2, which is an industrial class of manufacturing for a PCB. The next item here is highest performance. In all cases, when measuring how an output of a system will look, it's always best to look at the CEC weighted average efficiency. And with Ultraverter, it's the highest module level inverter efficiency in the world at 97.5. This is a great achievement. So when you talk about highest performance, you can talk about the kWh off the system, and you can also talk about the financial return that it yields. As I stated before, 87% weighted efficiency, CEC measured and listed on the CEC site. Each module is getting the maximum power point tracking. You have a very fast loop lock on the MPPT, and it's shade and soil tolerant on the roof. So the overall energy yield leads to better financial returns. Fast installation leads to lower installation costs. quick commissioning gets people back in the field fast for the next installation, feeding into transactional velocity. Serviceability always comes up when we go out and have conversations with our customers. 25-year warranty on the roof. That's a very, very important aspect of the system. Coming standard with the gate and blade is a 10-year warranty, and if you register the system, you get 5 years for free. This is the best in industry, head and tails above everybody else. UltraGate is never removed from the wall, but rather you're swapping and replacing UltraBlades if required. You can stock inverters and spare parts. It'd be fast and seamless for RMA, and always advanced shipments to keep uptime on the inverter out in the field. KACO, again, has been doing this business for over 20 years, and we understand the customer's needs. So, not in conclusion, but at the moment before we do get to Q&A, I would like to encourage people that are involved with this webinar or share it with friends. We are a growing team, and this is an exceptionally amazing opportunity. We're looking for a West Coast regional sales manager, a field applications engineer, and technical sales manager. And you can please be in touch through email with me to discuss those positions. Of course, we want to know where you can buy this product. We would encourage you to be in touch at KACO@kaco-newenergy.com, and we'll connect you with one of our channel and distribution partners. So that concludes the presentation. I'd like to ask MJ and Paul if they'd like to make any comments on what we've reviewed today, and then of course we'll open it up to the audience.
Thanks, Jon. This is MJ. I think I have some questions that we can bake in with the audience Q&A, and again, for those folks that are joining us late or missed the intro at the beginning, there is that Q&A box to the left that you can type in your question, and we are receiving a lot of questions, which is great. All right, sounds like, Paul, you may be on mute, or if you don't have any thoughts, let's just
I'm
go ahead.
I'm just going to defer to the audience on the Q&A.
Fantastic.
Okay, so hey, MJ, before we jump in, I'd just like to make a concluding statement here. Is that I think the intent of this presentation is that we're looking at the balance between the pros and the cons of all the solutions, and we're introducing Ultraverter because it really is a genesis. It's the next great technology of solar, which makes solar potentially more ubiquitous, safer, easier to use, and we improve the amount of labor that can get in the field and get this stuff done. So this is a product that we feel that enables solar to compete and win against natural gas, coal, and nuclear, and we encourage people to dive in on the questions.
Sounds good. Well, maybe let's start with some housekeeping questions or make sure that everyone's on the same page. You brought up the terms UltraBlade and UltraGate, and I just want to make sure that the audience is clear about what parts of the total solution those refer to.
Okay, that's a good point, MJ, and I'll go back to this slide, which really demonstrates what each piece does. So the Ultraverter 250 is a 250-watt AC-rated device. It's married one-to-one on the roof, on the rack, with the module. So one module per one Ultraverter, and then these all come down to the UltraGate. So the UltraGate is effectively a smart combiner box, and it integrates the Wi-Fi, and you have a capacity within the same enclosure of 2 kilowatt AC to 9 kilowatt AC, and the termination point of the string is the UltraBlade. So this is where the grid protection is done. You have your relays there, and it's also doing string protection too. So it's one blade per string. Is that more clear?
Yeah, definitely. That makes it more clear. And also, since some of this discussion will be, of course, on comparing the Ultraverter to more to other solutions that have been built in the past. So you had also pointed out that the Ultraverter itself had 97.5% efficient, or CEC rated efficiency. And I was wondering if the UltraGate then weighs into that, if it affects the efficiency of the total solution as well, and what the overall efficiency of the system would be.
It's a good point, and I think that rating systems has never been done. And if we look at the efficiency of any system that has a combination of products, you'll find that there's going to be a system efficiency, which unfortunately we don't have an industry standard for. But in general, just giving you an idea, the gate itself is 99.5% efficient, and the Ultraverter on the roof is 97.5. And again, that's a weighted efficiency, so as people understand the weighted efficiency, it's when the California Energy Commission really wants the power, and that's at about 75% of rated power. So the combined system is slightly lower than that, but we're talking about the inverter on the roof that is converting power at the highest level of any module level inverter in the world.
Sure. And then I think one other question, actually I seem to have lost it. So maybe we'll move on to a set of questions that a lot of people have brought up, which is, so you presented definitely some information as far as the warranty and the reliability that you bring to the table. But as far as O&M, what's recommended here? There is a 25-year warranty, but is there any additional O&M or any additional monitoring that you're recommending in order to make sure that the system is reliable over the lifetime?
Well, I think with module level power electronics, of course, you get the benefit of having that visual data, and you can make planned and scheduled visits to sites. So being able to schedule that maintenance is a vast improvement to the crisis, oh, my string inverter's off. Especially in a third-party owner scenario, a system goes off on a 5 kW AC string inverter, and the system is off. Basically, the cash register has stopped creating value for the owner. So by having a module-level inverter, you have a very robust system that has data flow in real time, and the maintenance can be planned and scheduled, and that's a huge advantage. Now, speaking of the 25-year warranty, again, I want to go back to the fact that KACO has been in business for 100 years, and they plan to be in business for another 100 years. When dealing with warranty, counterparty risk is real. Who am I taking a warranty from? And so you have to measure that. KACO has done an extensive amount of reliability testing on the devices in order to understand failure rates and failure timing. And they're prepared to put their balance sheet on the line to protect their customers. And this is important. That's why we've done so much testing on the product. If you look at the reliability data, it's significant. 3,700 hours of damp heat takes a long time to do. And it's a very impressive outcome. And we're not done yet.
Yeah, I think I'd love to dive into the reliability aspect. In terms of, so we see a lot of terms get thrown around: failure rates, mean time before failure, even looking from a high level, just looking at in-field data of performance ratios and system availabilities. That's a lot. A lot of this data is not easily found by the average residential installer. So how should the average residential installer look to reliability? How should they assess it? And what sort of metrics should they be demanding from their vendor partners?
Well, you mentioned MTBF. MTBF is a pretty blunt tool. It's not a particularly accurate definition. Our team has gone to the physics of failure, which is actually the analysis of how things fail. It is a practice coming out of University of Maryland. It's a very, very well-respected long-term reliability practice. It's used in automotive, it's used in aerospace, and we are taking reliability as a key differentiator because we've done so much work on it and because the product really does stand up to it. Annualized failure rate is a good understanding of how you might determine your O&M practices. As I said before, typical string inverters have a 1.5 to 2% annual failure rate. This is significantly below that. Let's see, what else could we talk about as far as the installer is concerned? Yeah, I mean, back to scheduling maintenance is very important, having the visibility into the system.
I mean, just even, you know, actually, I want to get back to the failure rate question in a second, but even from the average residential installer, you know, I think what we've heard is, you know, just understanding what sort of support they have from the vendor side if there is a potential failure in the field. So, you know, what sort of programs do you have in place? You know, installer says, you know, God forbid, there looks like something's wrong on the roof. What happens? What does KACO do in that situation then?
That's a great point, and thanks for raising it again. I covered it a little bit, but it's worth reiterating, and that is that with the Ultraverter, we have the ability to do remote updates and remote diagnostics, and that's an extremely important part of the system. So whether it's someone calling for a nuisance problem on the roof, or maybe they've had a tree fall on their house, or whatever it might be, the strangest things happen on the service line. And again, I go back to experience. KACO's been in this business for a very long time and knows how to keep people happy. So shipping the RMA right out of the gate so that there's no issue once it's been determined to be a failure of the device, but also remote diagnostics prevent truck rolls. And this is a really important part. Now, what happens if you have a grid change? So HECO, out in Hawaii, for example, if you have to do remote updating, Ultraverter can update over the air. So your entire fleet can be updated and compliant remotely without visiting one single site. At $350 a truck roll, that's something that an installer can put in their pocket rather than spend trying to service a system out in the field.
Right, that makes sense. I do want to go back to what you brought up about the failure rates. So you mentioned that the average string inverter, that's about 1.5 to 2% versus what you have found is with the Ultraverter around 0.05%, which definitely is drastic different. So, I would assume that this 0.05% is a per unit failure rate. And as a result, you know, if you think about the average system, of course, you're going to install more than one Ultraverter, right? So you're installing 20 or 30 Ultraverters. So on a per system basis, don't you essentially have the same failure rate as a string inverter? You know, you have 30x less failure rate, but you have 30 times the unit on the system itself.
No, the math is there. I mean, it's Telcordia is a standard, a reliability standard. So annualized failure rate is a calculated mathematical number. So the units, you have to look at the bottom of the slide here. We've had 3,700 hours on a multitude of units without a single failure. So one could say that, well, you're introducing more points of failure, but you also could say I'm introducing more ports of redundancy, but I don't have a binary outcome. I don't have a 5 kilowatt AC system going down and require getting out there. I mean, we're talking about the difference over 20 years for a solution is 0.05% annual failure rate over 20 years is 0.1% total. It's a really significant difference.
Right, yeah, and I guess the question there is, again, when you're looking at a per system level or a portfolio level, is there the same, as the incidence rate as far as a per system level seems to be similar, but I guess the point you're making is that it's not necessarily as critical of a failure?
Well, no. It's just a simple equation of, let's say, 20 units on the roof, right? That would be a fair size system. 20 units on the roof, and you have an annualized failure rate of 0.05% per annum. That's a total failure rate of 0.1%, right? Now you're talking about a string inverter at 1.5% per annum. So as you compare, whether it's a DC optimizer with a string inverter, or you're comparing to a just string inverter standalone, the delta between the reliability of the in-field equipment is still a significant gamut. It's a 10x improvement on reliability of solar systems by using Ultraverter.
John, I think, yeah, right. I think we might be off by 10x, but maybe to shift the question a bit then. Also, I mean, with the UltraGate itself, so so this testing that you're showing on the current side, is this only for the Ultraverter? I'm curious, with the UltraGate part of the solution, what has there been similar reliability tests done to it as well?
Yes, it's a good point to raise, and I think in all this reliability discussion we have to understand, and that's why we talk about annual failure rate. We have to understand that there's no such thing in any equipment that goes outdoors that there will be zero failures. So that's a starting point, and of course that's why we have such a robust service organization, and that's a really important item that all of manufacturers that put equipment outdoors have to face. We are, again, applying the physics of failure design principles and design rules to all of our systems. So whether it's the UltraGate, the UltraBlade, or the Ultraverter 250 on the roof, it's all receiving the same type of attention. You've raised a good point about the gate. And inside the gate, we have done the analysis of annual failure rates. So just to quickly off the top of my head, at 40 degrees C, which is 104 degrees F, over 20 years, with 8 hours of operation per day at full power, there's an annual failure rate of 0.6%. So yes, it's slightly higher than the inverter on the roof, but it's also sitting in someone's garage or on the side of the house. It's not up in the brutal heat environment of the roof and being thermally cycled as the inverter is on the roof. There's no power processing that happens in the gate. The inversion happens on the inverter in the roof. The MTBF of the gate itself is 538 years. So at what point do you say we have enough information to say that this is a very, very good system? Now, all this said, is KACO New Energy satisfied to ship the Ultraverter product as it is today? These are impressive reliability numbers, whether you're looking at the inverter on the roof or the gate on the ground. It is an impressive set of reliability items. But we're not done. We're not sleeping on this one. We continue to innovate. We continue to improve our reliability because ultimately, if we can make these systems go out 30, 40 years, the NPV value of the systems goes up significantly. And when you start securitizing assets, this becomes a very, very important part of your system. Reliability is a key differentiator for Ultraverter. And frankly, reliability is something that KACO New Energy really wants to make a standard. Why aren't we all testing the same way? What are our standards? There's certainly module standards. Let's have module-level power electronics standards. We really believe that that's the best way to go, and we're going to be working on championing that over the next several years.
In terms of those standards, what does that really mean, though? Standards for what part of the module-level power electronics?
Like a CEC standard, for example. Everyone knows what a weighted efficiency is. It's very difficult to game that system, shall we say. So when you start thinking about reliability, there's IEC standards for damp heat, for example. But is 1,000 hours enough? We would say that for maybe an inverter that's sitting in someone's shaded garage, that might be okay. But when you're talking about module-level inverters and module-level optimizers that sit on a roof in Arizona at 100 degrees on a good day, you have to really get the real data. And that real data is not 1,000 hours of damp heat. It's certainly higher than that. We believe that probably towards 3,500 is enough, but we've already gone beyond that without failures, and we're going to continue to go. So we'll do 4,000, we'll do 4,500, we'll do as far as we can go. We want to understand the physics of failure. That's really at the core of our reliability practice. I also want to mention, and it's worth mentioning again, is in an MTBF scenario, when you're looking at the bathtub, which everyone knows so well, the beginning of your life is the infant mortality curve as you quickly see failures off the manufacturing floor. This has been mitigated by KACO by focusing on Class 3 IPC manufacturing standard. Again, to repeat, there's three classes of IPC for PCBA construction. There's class 1, which is for consumer goods like mobile phones and others. There's class 2, which is industrial applications, and there's class 3, which is military and aerospace class. The difference between these classes is really the tolerance and the amount of solder fill that's required on the board itself. So we're talking about solder bonds. We're talking about chemistry on the PCBA itself. This is science. This is engineering. It's hard. And Ultraverter has this. And as I say, we're not done. We're still innovating. We're still improving.
Yeah, and I'm curious then. Well, first of all, there's a couple of questions as far as the applicability of the product. So, I introduced the topic from a residential standpoint, but I'm curious, what sort of market is KACO chasing with this product right now?
We're actually being chased. We're not chasing. Thankfully, we've had a really great job at warming up the market with several just super and supportive channel partners. And the residential market at 240 split phase is the first market that we are going to capture with the Ultraverter. We will move swiftly to the three-phase environment with this same technology platform, but that's coming soon. So I want to just be clear that the product today is for 240 split phase residential installations, or maybe even places where you can get in otherwise. So that covers Canada, the United States, and others. So we're really excited about the market we can capture immediately, and going forward, we'll probably have more announcements about three-phase offerings.
Fantastic. In the meantime, in terms of maybe some of the product itself, one of the things that you brought up was one of the things that you did bring up was the communications aspect and trying to really simplify the communications for the installer. And actually, maybe just the first baseline question that a couple of our audience members have, and I think I have as well, is even the communication between the Ultraverter and the UltraGate itself. What sort of protocol, or how are they actually communicating?
They're communicating via power line communications. So you're using the electrical series connected line to pass signals back and forth. But I want to be clear that the UltraGate is not commanding the Ultraverter in any way past commissioning. So it is commissioned and then it runs autonomously and independently. So there's no central control here. That's a very important element. The other thing is that the way this system is commissioned is you connect the gate to the local Wi-Fi internet point, and then you connect your mobile device to the gate, and you commission via a very rich application which has graphics, and you can move things around, and you can recommission, and you can do all sorts of stuff. The final element here is that in a PLC environment, it always can be a lot of noise. So we mitigated that noise by adding a high bandpass filter, which gives us deterministic performance. So we're blocking the grid noise from the system. We're blocking the string noise. We're also channeling the signal out to the inverters, so we get a very clean and private channel. And in fact, a series connection is better for PLC than a parallel connection, because all the units are seeing the same signal level. And that's very important when you're trying to remote control units out on a string. Is that helpful to understanding that a little bit better? Because I didn't obviously see the question, but you're relaying it. So I'm hoping that I did answer your question.
Yeah, I think so. I think one thing that might bear a little bit more explanation is, at the beginning you're saying that, post-commissioning, the UltraGate doesn't actually command any of the Ultraverters. So that raises two questions in my mind. One, what is its command role, before or during commissioning? And then, let's start there.
Okay, so the way the system is commissioned is just as I said before. You have a tablet or you have your mobile phone. You connect it to the Wi-Fi point of the gate. The gate is connected to the local internet point. So there's no Ethernet cables to be pulled. You then have an application, the KACO Ultraverter application, and you go through a series of steps on that mobile device that says, okay, how many units are in this string for this particular blade? And then you commission blade 1, blade 2, blade 3. So each one is commissioned. After that commissioning point, whether it's sunrise or sunset or any sort of failure intermittently because of grid issues, the system knows where it is and what it should be doing. Now, if there is an RMA, or if the person decides to change the array, maybe expand the string by a couple units, maybe they started with an 8 string, they want to add 2 units, so they want to add 10, they would have to recommission the system again from the gate. But after it's commissioned, the system runs autonomously and doesn't require additional commands. Now, you might be leading to a really good point to make, which is ancillary services like reactive power, frequency ride-through, voltage regulation, etc., is all done inside of the gate. And this, of course, can be remote accessed through a secure and private network to update the system software. And you can also do energy services going forward. Now, this is probably a future iteration because people don't get paid on residential environments for delivering reactive power, for example. But in the future, I would almost put money on it that big TPOs like Sunrun and SolarCity and others are absolutely looking at bundling residential systems to be a qualified facility and provide ancillary services. Now, this might be going beyond where we need to talk about for this, but power quality is required in order to deliver energy services. And Ultraverter, hands down, has the absolute superior power quality as compared to microinverters and other offerings on the module level. So it's an important point to make. I thought it was too technical for this particular talk, but if someone has a question about power quality, we're happy to talk to you about power quality and how that might relate to energy services for a third-party owner of solar assets.
Sure, I think that broader topic might be a lot more than we have time for, but I think that's a fairly bold claim to say that you have the highest power quality, and would just ask you to maybe elaborate on that and what metrics are you looking in order to evaluate how, the quality of that power that you're delivering itself for these services?
Right, it's a bold claim, you're right, and it's a true claim. This is information that we've gathered from doing a variety of testing on every product that's available in the marketplace that we could see, and we see that module-level power electronics, specifically microinverter offerings, do not have good power quality. Ultraverter does. So in most cases, competing microinverter technology doesn't reach 0.99 power factor until approximately 50% of rated power. In comparison, Ultraverter is at 0.99 power factor at less than 20% of rated power. So when you're called by the grid operator, hey, give me reactive power now, well, if the competing product is below 50% of rated power, which is a large percentage of the time, they can't deliver that service, whereas Ultraverter can deliver that service. And yes, it's observed data in the field. Is there a standard for tested power quality like the CEC for efficiency? No, there isn't. But if someone's interested in power factor, we'd be happy to demonstrate and certainly show the data set that we understand to be true.
Sure. So we're running out of time here. I do have one more question about the expansion of services. So maybe aggregated grid services might be a little bit farther out in the future, but something that a lot of residential installers are thinking about now is the integration of storage. And I was wondering if you might be able to comment on the compatibility of the solution with storage.
Storage is obviously coming, and it's a very exciting topic for everyone. It's not here today, and the current Ultraverter does not have a storage option. Will future Ultraverter systems have storage-ready options? Without a doubt. It is something that we're thinking about, looking at, but the storage behind the fence, whether it's residential or commercial, is not really a market today. It gets a lot of attention, and certainly in self-consumption markets that Hawaii may become and other markets may become, that will be a driving factor. We're watching those markets very carefully. We're involved with those discussions, but people aren't selling volumes of that product today. And we're going to be ready when the market is ready to provide our customers with a storage-ready solution. And it is on our roadmap.
Certainly, that makes sense. So I'll give you a little bit of time to include any final thoughts, but before we get to that, just a couple of notes from me. First, again, the slides are available for download with the Download Slides widget at the bottom of the screen. Furthermore, this webinar will be archived on the Greentech Media's site, so if you want to go back to something that we mentioned earlier in this webinar, you can do so at greentechmedia.com. And then finally, there are a lot of great questions that came into the back end. KACO will have a copy of them, and so I also encourage you to reach out to the contact information that Jon provided, and hopefully we'll be able to get your questions that we couldn't get to answered. With that in mind, Jon, any final thoughts that you want to leave to our audience this morning or afternoon?
Well, first I want to thank you, MJ and Paul, for being involved with this. It's been a lot of fun building this story together and being really critical of our data we're presenting. I think that the only way that we can be serious about making solar ubiquitous is if we're honest with ourselves. And I think that this material today that was presented represents a very honest look at where is a string inverter, where's a string inverter with a DC optimizer, where's a microinverter, and of course, how does Ultraverter compare and compete against these products? So I want to conclude by simply reiterating business intelligence solar that is the driving factor behind Ultraverter, where we're listening to our customers. No customer wants to do additional work or add more cost in hardware to be rapid shutdown compliant, whether it's 2014 or 2017 coming forward. Ultraverter doesn't require any additional work or cost. Of course, increasing our customers' transaction velocity allows them to get up and get down on projects with a high level of quality and safety, which means they can go on and do a new job. That's super important. To Paul's point, module-level power electronics increase significantly the MPV value of a solar system while also increasing the system size of capacity, which means that it reduces the cost of acquisition. By mitigating headache risks and doing the crosstalk mitigation communications that we've done with the application and the whole shebang on the IT side, it really makes it very easy to commission. Again, part of the transaction velocity. Having an ultra-reliable system with the highest yields means you do not go back to the same system, but yet you have the highest performance. And having a fair lifetime cost is always a consideration. Price is part of this equation, and then serviceability is key. So if you do have to go out into the field, you want to have it easy to service, not only safe, but quick. So having 3 SKUs to replace the entire system makes it absolutely easy and low cost for distributors. I think that would be my conclusion with the Ultraverter. Thank you, MJ, and thank you, Paul.
Well, thank you, Jon. Thank you, Paul, also for presenting as well. And thank you to our audience this morning or afternoon or maybe even evening, depending where you are. Once again, this webinar will be archived on greentechmedia.com, and thanks for joining. Take care.